Hello, my name is Shauna and I will begin by presenting the code for our program. So we first begin by initializing the libraries that will be used to power the functions later on. Then we define the CPU frequency to 1 MHz. This will help to decide how fast the timer will run. For this project, we were required to use two delays, one for 500 milliseconds and one for 1 second. So for both delays, what we did was we coded for 200 milliseconds using timer 0. And for the 500 millisecond delay, we ran it twice. And for the 1 second delay, we ran it 4 times. Now, we did actually try to run the 1 second delay using timer 1, but for some reason, no matter what we did, it didn't work. So we just did this. Next, we initiate the metric card numbers. So into this array, so this first one, A18KE4004 is Abbott's metric number. This one, A18KE0042 is my metric number. And the last one, B19EE0049 is Eddie's metric number. So these three metric numbers will be displayed later on. So now we come to the beginning of the program. So we start the program by initiating the ports. So we define port A and D as inputs, port B and C as outputs. Port A will be where the switches are, and port D will be where the interrupt switch is. Port B is for the 7-segment display, and port C is for the 8 times LED. Now these 3 lines of code here is to initiate the interrupt. So GICR is to enable the interrupt in int0 and int1. MCUCR is to set the interrupt to be activated at rising edge, meaning if you press the button, then the interrupt will straight away run. SEI is to enable the global interrupt. Now, when the program is running, if you press switch 0, which is pin A, we'll first blank out the 7-segment display. Then it will start running. So it will start running as throughout the length of the array. So in this case, it will first run Abbott's metric number. So in between, we'll have a 1 second delay. The same will go when you press switch 1. Switch 1 will run metric number for me. And as you go down, switch 2 will run the metric number for Eddie, using the same format exactly. Now, if no pin is pressed, port A, B, and C will be initialized to 0, will be cleared. Next, at the end of the whole program code, we have the interrupt service routine for both pin in0 and in1. So, since in0, for both interrupts, we run on port C. So first we clear port C, and then for in0, we were required to have the LEDs blink 5 times, all 5 of them, with a delay of 500 milliseconds in between. So this is what we did. So by initializing this hex code to 1, and then the delay clear, and then delay again, so a loop. And then after this loop is done, it will initialize the interrupt pin to 0. Clear it. Yeah. So we go to pin in1 now. So for this one, when this button is pressed, first it will clear the LEDs, and then after it will run this is the sequence of the running light in hex code. And then this is the array. So once we initialize this array, we put in a for loop, and we'll run every element in the array. In between, we have 500 milliseconds. And at the end of it, we will clear the LED and clear port D. And that's all for me. Thank you.
Hi, my name is Eddie Hakim bin Mohammed. I'm from Group 7, and I'll be presenting the demo version of the simulation. So before that, I would like to clarify something. This is AVR Simulator IDE that we are using. We are not using Proteus software. We are going to simulate using AVR Simulator. As you can see, there are we preset the clock frequency to 1 megahertz. We have set the port for 8 times LED to port C there, because it is what we have coded to port C to become an output, and our 7-segment display is set to port B. So therefore port B and port C is our output, as stated in the coding before. So yeah, we preset everything. We try to simulate at the rate ultimate, because the time going on in AVR simulator is very slow. So to get that 0.5 second delay, we need to run it at an ultimate rate. Yeah, I would like to clarify something of this AVR IDE. The time going on in this simulation and the time going on in the real world is totally different. For example, the time for this AVR simulation to achieve 0.5 second is equivalent more or less 20 seconds in the real world. So therefore it is very slow. So when I will to run the simulation, the program will run very slow. It run as as we coded to be, because we coded it to have a 0.5 second delay. So therefore it will have a 0.5 second delay, but it's just that waiting in the real world, it is about 10 second to 20 second delay. I don't know what's going on with this AVR simulator, but there is this issue, and we have been trying to find out the solution for it, and we have not able to find anything. So let's without further ado, let's jump right into the simulation. The preset clock is 1 megahertz, and let's just get to it. So I will simulate the program. So the first thing I will do is I will show that the 7-segment display to display the metric card number. So there are 3 switches to do that. We have set the PA0 to be switch 0, PA1 to switch 1, PA2 to switch 2, interrupt 0 INT 0 to become interrupt 0, INT 1 to become interrupt 1. The interrupt program will light up this 8 LED bar graph, 8 LED bar, sorry. So I'll on switch number 1, for example, switch 0. So what they'll do is as you can see, it will display the letter A as the code that Chopna has tell you just now. The first switch will display my friend Abbott's metric card number. So that's why it will be A, and then switch to 1, and then switch to 8. Here you can see that it does not switch as soon as possible. As you can see here, it took about 10 seconds each time, or in this case 20 seconds, because the 7-segment display, we have put the delay to be 1 second. 1 second delay is equivalent to 20 seconds in the real world, but in this AVR. That is why the program is running very slow. Since the program is running very slow, to show you that this program runs exactly as it should, I will fast forward this video. So switch number 2 will show Chopna's metric card number. So as you can see now, we are starting with my metric card number, which is switch number 3 PA2. It start with the letter B. And as you can see, that is my metric card number, and all the metric card number has been successfully displayed using these three switches, PA0, PA1 and PA2. So the next part of this demo will be explained by will be simulated by our friend Abad. Abad, you have the floor.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Aboud and I would like to present our interrupt part. If we start the system, then we click BA0. It will show us the first student's matrix, as you see here, the main programming, and we interrupt 0. If we interrupt 0, the main programming will stop, and the LED part C will start from 0 to 7. All of them will work. Turn on and turn off for 5 times. Now the main programming started, and if we interrupt with 1, the main programming will stop, and the LED will start from 0 to 7. Then it will return back from 7 to 1 to 0, from 7 to 0. Now we can see the LED is done, the main program started again, and the same thing will be after if we interrupt with anything else, or if we take another my friend's matter. Thank you. This is all my presentation.